All right, so here we are going to be drawing the angle in standard position, finding the measure of the reference angle and a positive and negative coterminal angle. So if I were to take negative 473 and try to figure out where that lies, the first thing I want to do is make sense of that by kind of taking it back to 0 to 360. So if I take negative 473 and add 360 to it, I get negative 113 degrees. So if I were to add 360 degrees again, that's going to take me down to 247 degrees, which means that I am in quadrant 3. So now that I know that I'm in quadrant 3, the next thing that I need to do is find the reference angle. So when I do a negative angle, I am going to go around one time because I went one time here to 360. And then I'm going to actually go to negative 113, which just means a little bit more. This is my coterminal angle, which would make this my coterminal with 247 degrees, as if I were to do this. Okay, that's 247 degrees. I'm not doing that because it told me that I'm going to go to negative 473. So now I need to find the reference angle. So the reference angle is going to be the angle that's right here. So I have to figure out how much of the distance there is from here to here. So what I could do is take my 247 degrees, because that's what this is, and I can subtract 180 degrees because this amount right here is 180 degrees. So if I were to subtract that, then that's going to go ahead and give me my 67, and then that's what is going to be considered to be my reference angle. Okay, so remember the reference angle is an acute angle going from the terminal side up to the x-axis or down to the x-axis. All right, so I have my reference angle as 67 degrees. I'm going to find my coterminal that says negative and positive. Well, when I added 360, I still had a negative angle, so I can let that be coterminal. And then I added 360 twice in order to get 247. So I've got a negative and a positive right there. So now let's take a look at 13 pi over 7. So I have to make sense of that number. This is almost 14 pi over 7, which is almost 2 pi. So if I'm almost 2 pi, I'm in quadrant 4. Okay, so if I'm here, I've got to find my reference angle here. I'm in quadrant 4, so I draw my terminal ray. I'm going around in the positive rotation, so counterclockwise. Now I need to figure out what my reference angle is. So remember, the reference angle is from the terminal side to the upper x-axis. So what I could do is figure out 2 pi, which would be one full rotation. So think about it like this. I'm going to figure out one full rotation, and then I'm going to subtract this amount, and then that way it'll leave me with this. So if I go 2 pi minus 13 pi over 7, then that's going to be 14 pi over 7 minus 13 pi over 7, and that's going to give me pi over 7. So my reference angle is pi over 7. All right, now let's take a look at my coterminal. So I'm going to add 2 pi, and then I'm going to subtract 2 pi. So when I add 2 pi, I get 27 over 7. When I subtract 2 pi, I get negative pi over 7. All right, so for each of the angles theta described below, determine the quadrant or the axis in which the terminal side of the angle lies. If no such angle exists, state why and completely explain your reasoning. So let's take a look at this. I've got cosine is less than 0. So remember, when cosine theta, which is x over r, remember the r is always positive, right? Especially on a unit circle, it's just a 1. All right, so then that means in order for cosine to be negative, then that means my x value has to be negative. And so where are the x's? Negative. So they are negative on the left side of the y-axis. Okay, so that means if I were to draw this out, I am on this side. Cosine is negative here. And then it says, where is tangent also negative? So remember, if tangent is defined as y over x, and we know that x is negative, right? We know that the x is negative, then the only way for tangent to be negative is if their signs are opposite. So this is plus plus, this is minus minus, this is minus plus, and this is plus minus. So tangent in quadrant 3 is going to be positive, but tangent in quadrant 2 is going to be negative. So we know that the y value would have to be positive in order for that to work out. So we are in quadrant 2. All right, so now let's take a look at cotangent. Cotangent is undefined. So let's remember what cotangent is the reciprocal of tangent. So cotangent is x over y, and the only way that it's undefined is if y is equal to 0, because y is in the denominator. So we know that the y value has to be 0. So if the y value is 0, then that means I'm right here on the x-axis. So now let's take a look and see what this condition says. They're saying, hey, cosine is less than 0. Okay, get here. So cosine is less than 0 over here on this side. So that means that the only way that we could have cosine to be less than 0 and cotangent to be undefined is if that terminates on the negative side of the x-axis. Okay, so we're not in a quadrant, we're actually going to be right here. We're going to be anywhere right here. The terminal ray has to end on the negative x-axis in order for this to be true. Okay, so now it says the terminal side of an angle alpha. So this is how you can draw an alpha. You come down and then you go like that. So again, practice drawing that. Anyway, so the terminal side of the angle alpha passes through the points given below. Find the exact value of each of the 6 trig ratios. So the first thing that you want to do is you want to take your coordinate plane and you want to plot the point 5, -3. You are going to draw the ray, and then you are going to make it into a triangle that's 90 degrees up to the x-axis, and then you're going to label your triangle. So we need to be able to label this. So this would be obviously 5, and then this is going to be -3. Okay, so far this is what we should have. All right, so now the 6 trig ratios. So in order for me to have my ratio, I also need to find the hypotenuse. So one of the ways to do that is to use Pythagorean theorem, since I didn't say that you had to do it a specific way. So we know that the radius is the hypotenuse. So let's just go and find that. So we have r squared, or c squared, is equal to 5 squared plus -3 squared. And we end up with the radius being plus or minus 34. Well, we know the radius is always going to be a positive. So we know that the radius is going to be the square root of 34. So let's just put the square root of 34 right here. Now we can go ahead and do our ratios. So sine is going to be, and again, let me just make this very clear. the angle of alpha is always the angle that's formed by the origin, okay? So it's always going to be the angle surrounded by the origin. So here we have opposite over hypotenuse, then we have adjacent over hypotenuse, and then opposite over adjacent, and then each of those reciprocals. All right, now let's see what we're going to look at on the second one. So we are in quadrant 3. So we went to the left 3, down 2, make yourself a triangle, and let's go ahead and find the radius. Okay, so we've got -3 squared plus -2 squared. We end up finding plus or minus rad 13, which means we only have positive rad 13. So once you've done that, then you can do your ratios. So again, always the angle surrounded by the origin. So we've got sine of alpha is opposite over hypotenuse. Okay. Cosine adjacent over hypotenuse, tangent opposite over adjacent, and then each one of those reciprocals. Okay. This helps you. You can just identify the x and the y on each of those. All right. So here we say that sine of alpha is -3 over 5 and tangent is negative. Use this information to answer the following questions. In which quadrant does the angle alpha terminate? And explain your reasoning. All right, so obviously if sine is negative, then that means that we are in quadrants 3 or 4. Right? Because sine is the y value, and the y value is negative in 3 and 4. Between quadrants 3 and 4, tangent is negative in quadrant 4. Because when you take tangent, tangent is y divided by x. Tangent is positive in this quadrant, and it's negative in this quadrant. All right, so if sine of alpha is equal to y over r, and we have -3 over 5, right? Because that's what the ratio it is that they gave us. Then y is -3. So alpha must terminate below the x-axis, which is why we said 3 or 4. If tangent of alpha is y over x and it's negative, then the x value needs to be greater than 0, right? Because if the y value is negative, in order for tangent to be negative, then the x value has to be positive. Therefore, it's going to terminate in quadrant 4. It says draw and label the reference triangle for alpha. Find the exact value of the other 5 trig functions. All right, so when you're given this ratio -3 over 5, then just draw your triangle. Right? The angle is always by the origin, so opposite over hypotenuse. We don't know what x is, so we can use Pythagorean theorem to find the value of x. And we know that x is either positive or -4. But remember, we're in quadrant 4, so this is where it's going to determine whether or not it's plus or minus 4. So when you're in quadrant 4, it's going to be a positive number. All right, so the x is 4, the y is -3, and the radius is 5. Using that information, here are the other trig functions now. Adjacent over hypotenuse, opposite over adjacent, and then their reciprocals. Okay, let's see how well you do on this one. All right, suppose secant theta is -3 over 2 and tangent theta is positive. All right, so one of the things I want to do, if I haven't done this already, is give you a little acronym here saying all students take calculus. And what that means is in quadrant 1, all trig functions are positive. In quadrant 2, the only trig function that's positive is sine. In quadrant 3, the only trig function that's positive is tangent. And then in quadrant 4, The only one that's positive is cosine. So all students take calculus is another quick way to determine what quadrant you're going to be in. All right, so secant, -3/2, tangent is positive. On A, what quadrant does angle theta terminate? So let's take a look at that. So secant, you have to remember that secant is the reciprocal of cosine. And so if cosine theta is x over r, secant theta is r over x. Remember that the radius is always positive, and in order for this to be negative, then that means that my radius is 3 and my x value is -2. Okay, so what does that mean? Well, that means we need to kind of draw it or think about it. Where is cosine or secant negative? And so we are looking here. Cosine is negative here, which means the reciprocal is negative. And then out of these two quadrants, where is tangent positive? So tangent is positive in quadrant 3. So here we go. If secant theta is r over x, which is equal to 3 over -2, then x is equal to -2, which means theta terminates to the left of the y-axis. If tangent is y over x, then y would have to be negative because my x is already negative and we want it to be a positive. So y is going to have to be negative, which means that theta terminates in quadrant 3. So we're going to draw this. All right, so the only thing is that we have our -2 and we have our 3, but we need to figure out the height of the triangle. So we need to be able to do Pythagorean theorem so that we could figure out the y value. And the y value is plus or minus rad 5, but remember you're in quadrant 3, so the actual value of the y is going to be negative. Okay, so once you have that, we can identify the x, we know the y, and now there's our radius, and then we could do the 6 trig functions. Remember that it's always of the angle closest to the origin. Theta is always right here, okay? So these are the trig ratios. Okay, so now let's take a look at the next one. Cosecant A is 7/3, cotangent A or alpha is negative. All right, so let's figure out what we're doing here. So again, cosecant is reciprocal of sine, so sine of alpha is 3/7. Cotangent is the reciprocal of tangent, so tangent is y over x, which means cotangent is x over y. In order for that to be negative, then that means either the x or the y has to be a negative. Looks like the sine is y over the radius, which means the y value is 3. Okay, the y value is 3 and the radius is 7. Okay, so if we could take a look, we want to make sure that we understand our numbers here. So our y value is 3, our radius is 7. Okay, so we need to figure out where we are. So we are a positive for sine or cosecant. Okay, we're positive, so we are in quadrants. Oh, I take that back. Sine is positive in 1 and 2. There we go. And then cotangent is going to be negative. Well, it's the same kind of thing as tangent. All are positive here. Tangent is positive here and here. So that means tangent is negative right here. So that means we're going to be in quadrant 2. All right. So if cosecant theta is r over y, and that is equal to 7 over 3, then y is equal to 3. So alpha terminates above the x-axis, which is quadrants 1 and 2. All right, if cotangent is defined as x over y, and you already know that the y is positive, then the x has to be negative, okay? The x is negative, then that means we are going to be in quadrant 2. So we're going to draw and label that. Okay, so again, we're going to be in quadrant 2. We know that the y is 3. but we don't know the x. Okay, so we know the y is 3, the radius is 7. So now we're going to do Pythag to figure out the x value, plus or minus 2 rad 10. Remember, we are in quadrant 2, so that means we are looking at negative 2 rad 10. Okay. Now that we have all of those pieces of information, now we can just do the ratio. Remember, the alpha is right here. It's going to be the angle closest to the origin. And then here are the ratios. Okay. All right, getting close. All right, terminal side of angle beta lies in quadrant 2 along the line 2x plus 5y equals 0. Order the values of sine b, beta, tangent beta, and cosecant beta from least to greatest. So the first thing you need to do when you have a linear equation is to solve for y and graph that. This is going to be your terminal side. This is your terminal ray. So if I were to do this, I've got negative 2 over 5x. Okay, so if I were to graph, I don't want to give away too much here. We should be able to come up with the triangle right here. Okay, so there's the point at the origin and there's a point here. This is my ray, and you're always drawing your triangle down to the x-axis, and your alpha or your beta or your angle is always right here, closest to the origin. So now what I need to do is find the hypotenuse. Okay, so if I find the hypotenuse, a squared plus b squared equals c squared. Remember that their radius is always going to be positive, so I got positive rad 29. Okay, so there's my triangle. And then I want to make sure I identify my x, my y, my radius. And so sine of beta, and again, beta is right here, then is opposite over hypotenuse, tangent, and cosecant. And so now you're just ordering it from least to greatest. So you can approximate this. You can use a calculator. It doesn't matter to me, but already you know that this is positive, this is negative, this is positive. So we should already make the determination that tangent of beta is smallest. Okay, and then let's just approximate 29, like between what two numbers is this? And so if I take a look, I know that 5 squared is 25 and 6 squared is 36. So this is in between 5 and 6. So sine is like saying, oh, you're like 2/5 or between 2, 6. And this one is saying you're like 5 over 2 versus 6 over 2. So this one over here is a whole number. And this is a number that's between 0 and 1. Okay, so beta between 0 and 1. So that means sine is going to be the next largest, and then finally cosecant is going to be the largest. All right, so let's see if you can do this. All right, tangent is negative and secant is greater than 0, so it's positive. Secant, remember, is the reciprocal of cosine, so the reciprocal is also positive. So tangent is negative in quadrants 2 and 4. All right, this is opposite over adjacent. Find the values of cosecant and also cosine. All right. So in order for tangent to be negative, we already said we were in quadrants 2 and 4, and then cosine is positive in quadrants 1 and 4. So that means the only quadrant that they have in common is 4. Okay, so let's look at a possible explanation for that. If tangent theta is y over x and it's negative, then that means x and y have opposite signs. Okay, which means that theta is going to terminate in quadrant 2 or 4. Okay. Okay, if secant is equal to r over x and that's positive, we know that x is already greater than 0, okay? Or I'm sorry, no, we know that in quadrants 2 and 4, oh no, sorry, cosine is positive, 1 and 4. Then x is greater than 0, which means that the y value has to be negative, right? So cosine is 1 and 4. All right, the only one in common there is going to be quadrant 4. So let's draw this. All right. So we've got opposite over adjacent. Remember, this is always your angle. And we knew it was quadrant 4, so that meant that we have the x is 3 and the y is -4. Using Pythag, we find out that the radius is either positive or -5. Always positive because it's the radius, okay? Always positive because it's the radius. Let's go ahead and identify our x, our y, and our r. And then from here, it just said, the directions said, find cosecant. Remember, cosecant is the reciprocal of sine. So if sine of your angle theta is -4/5, then that means the reciprocal of that is going to be -5/4. And then cosine is adjacent over hypotenuse.